Hello everyone. Welcome to another episode of Deep Dive Knowledge. Hello. I would like to discuss the recent announcement by Google DeepMind regarding their new AI models, called Gemini. Can you tell me more about Gemini's performance compared to GPT-4?
Certainly. Gemini's performance, as reported by Google DeepMind, surpasses that of GPT-4 across various benchmarks. This is a significant achievement, as it marks the first time in 4 years that any model has taken the lead from OpenAI's GPT series. Gemini Ultra, the flagship model, is specifically designed to achieve state-of-the-art SOTA benchmarking and outperforms GPT-4. However, it is important to note that while Gemini's performance is impressive, we should not overlook the upcoming release of Bard Advanced by Google in early 2024. Bard Advanced is expected to be a strong competitor for Gemini, and it would be interesting to see how the two models compare in terms of performance. To summarize, Gemini has demonstrated superior performance compared to GPT-4, making it a remarkable achievement for Google. However, it is important to await the release of Bard Advanced and further testing to determine which model is truly superior.
Thank you for the insightful summary. It's impressive that Gemini Ultra has outperformed GPT-4 on benchmark tests. Could you elaborate on the specific academic benchmarks where Gemini achieved state-of-the-art performance?
Gemini achieved state-of-the-art performance on several academic benchmarks. According to the report, Gemini outperformed GPT-4 on benchmarks such as reasoning and understanding, solving math and coding problems, and other real-world testing scenarios. These benchmarks have been designed to evaluate the performance of AI models in various cognitive tasks and provide a measure of their capabilities. Gemini's performance surpassing GPT-4 on these benchmarks indicates its superiority in terms of problem solving, reasoning, and comprehension abilities.
That's fascinating. It seems that Gemini's performance extends beyond just language processing tasks. Could you explain how Gemini achieves this broader understanding of the world by incorporating multiple data types?
Gemini achieves a broader understanding of the world by incorporating multiple data types through its native multimodality. Unlike traditional language models that only accept text as input and generate text as output, Gemini is designed to work with different types of data from the very beginning. Gemini is pre-trained on multimodal data, which includes not only text but also other modalities such as images, audio, and video. This pre-training allows Gemini to learn to understand and reason about different types of inputs, enabling it to have a more comprehensive understanding of the world. The incorporation of multiple data types in Gemini's training process helps it to capture and learn from the rich information present in different modalities. For example, by analyzing both text and images, Gemini can learn to associate visual content with textual descriptions, leading to a more nuanced understanding of the context. By being natively multimodal, Gemini is able to seamlessly process and reason about diverse inputs, making it more effective in various domains. This capability sets Gemini apart from traditional language models like GPT-4, which are limited to working with text alone. In summary, Gemini achieves a broader understanding of the world by incorporating multiple data types through its native multimodality, allowing it to process and reason about different modalities from the ground up and leading to state-of-the-art capabilities in various domains.
Thank you for the detailed explanation. It's impressive to see how Gemini's native multimodality enables it to process and reason about different types of data, leading to a more comprehensive understanding of the world. In the report, it mentions that Gemini models have a 32K context window, Could you explain what this means and how it contributes to Gemini's performance?
The mention of Gemini models having a 32K context window in the report refers to the maximum amount of text that the model can consider as input during its processing. In other words, it represents the size of the text window that the model can see and take into account when generating its output. Having a larger context window allows the model to have access to more information and context, which can potentially improve its performance. However, it has been observed that models tend to forget a significant portion of the context if the window size is too large. This is referred to as retrieval failure in the report. Gemini models are reported to effectively utilize their 32K context window, implying that they can make good use of the available context without suffering from retrieval failure. This ability to effectively utilize the context is likely one of the factors contributing to Gemini's performance. By considering a sufficient amount of relevant information, Gemini can generate more accurate and contextually appropriate responses, leading to better overall performance compared to models with larger context windows that may struggle with retrieval failure.
Thank you for clarifying the concept of a context window and its significance for Gemini models. It's interesting to learn that Gemini can effectively utilize its 32K context window without experiencing retrieval failure. In the report, it mentions that there are still limitations to be addressed, such as hallucinations and high-level reasoning. Could you provide more details on these limitations and any insights into how Google DeepMind plans to address them in the future?